everyone, we're in section 3.5, continuing on from the last part. So I'm on page, 270 here. So now what we're going to talk about is ways to actually solve linear inequalities. So we need to just talk about what things we can and can't do. So the first part of this is something that's probably going to feel very familiar to you already. You probably would have done this without me even saying anything. So if you have an inequality, you're basically allowed to either add to the same side. You can add whatever you want. You just have to add it to both sides, or you can subtract whatever you want. You just have to subtract it from the both sides. And you can do that for any inequality with any sign. So whatever you do to one side, you do to the other. So I just want to show you kind of just two ideas of this addition principle. So like I said, I think this is something probably a lot of you would do without even any instruction on this. So let's say that I want to solve this inequality. X plus 3 is less than 7. So just by looking at this, you probably know you'd want to subtract the 3. So the only other plot twist to this is now you have to put your final answer on a number line and an interval notation. You don't have to put it in set notation. So if you want to pause the video and just do that, hit play when you're ready. So I have x is less than 4 as my answer. So here's my 4. I need to shade this way, and I'll give an open circle or a rounded bracket, whatever. And then my interval notation starts at negative infinity and continues on to 4. Infinity always gets a round, and 4 is not included, so it also gets a round. So this is the idea of the addition principle. So why don't you do this one? How about x minus 5 is greater than or equal to negative 2? So give that a try. Hit play when you're ready. Remember, put it on a number line and an interval notation. Okay, so first I'm going to add 5 to each side. Whatever I do to one side, I have to do the other. So this is going to be x is greater than or equal to 3. So then if I put this on a number line, so here's my 3. I'll use a square bracket or a closed dot, whichever. So here's x is greater than or equal to 3 on a number line. And then here it is in interval notation. So I start at 3, I go to infinity. Infinity always gets the round. So that's the addition principle. So multiplication and division are actually a little bit more tricky. So what I want you to do on the next page, I actually want you to pause the video and I want you to work through the entirety of this example on your own. Hit play when you're ready and we'll go through it together. So to begin, so I have this whole inequality. So we're starting with the inequality 2 is greater than negative 4. So to begin, you want to multiply each side by negative 2. So if I multiply 2 by 2, I get 4. And if I multiply negative 4 by 2, I get negative 8. So is this inequality a true statement? Yes, it's true. All right, just hang with me here. I'll get to the point in a moment. So now going back to 2 is greater than negative 4. I want you to multiply each side by negative 2 and write down what this becomes. So 2 times negative 2, this will be negative 4. And then negative 4 times negative 2, this becomes positive 8. So I didn't flip any inequality sign, but is this true still? It's not. Negative 4 is not greater than negative 8, or not greater than 8. So this is false. So this is kind of illustrating one of the issues. So I'm not done yet. Give me 1 second. Going back to the original inequality, 2 is greater than negative 4. Now I want to divide each side by negative 2. 2 divided by negative 2 is negative 1. Don't change the inequality for now. Negative 4 divided by negative 2 will become positive 2. So once again, is this a true statement? It's not. It's false. All right. So the whole gist here is that if you're multiplying or dividing by positive numbers, then the inequality is fine. But there's an issue when you are multiplying or dividing by negative numbers. And so that is what should clear up what this next rule says. It says, so let a, b, and c be real numbers, and c is not equal to 0, so then the following holds. So if c is a positive number and a is less than b, then ac is less than bc, or a divided by c is less than b divided by c. So if c is less than 0, so if c is negative, then when you do this, so if you have a is less than b, after you multiply each side by c, look what happens. So just to make this nice and clear, because c is a negative number, sorry about that, because c is a negative number, I have to flip the inequality. So maybe I'll just underline this a little bit too. So when you've got a negative number, you have to flip the sign of the inequality. That is the name of the game here, and this is true for no matter which inequality that you have. If your inequality has an equal to part on it, then you just leave that in the flipping. All right. So now let's get down to business here, and we're going to put our answer again on the number line and an interval notation. So starting with the basics. So if I have something like 3x is greater than 6, so this case is all hunky-dory, right? Because if I just divide each side by 3, 3 is a positive number, I get x is greater than 2, no problem. So I can put this on a number line. So here's my 2, where my x is greater than 2, on the left or on the right. They're greater on the right. And I'll put an open circle here. So, and then my interval notation, so I start at 2, and then I continue on to positive infinity. So there's kind of the idea, the basic idea, and this is totally fine when you've got positive numbers. It almost feels like working with an equation. Now let's take a look at working with something negative. So what about if I have negative 2x is greater than or equal to 8? So this is the part that you have to pay attention to. You're going to divide both sides by negative 2, but when that happens, now you need to flip this. So this will become x is less than or equal to negative 4. And put that on a number line and an interval notation as shown. So the thing to pay attention to here is what you are multiplying or dividing by. It does not matter if this number here, if you have a negative in here, it's about what you're multiplying or dividing by. So what I want to do is I want to give you a couple of examples now to try this out. So why don't you go ahead and do, how about negative 5x is less than 10? And then let's do 7x is greater than negative 21. And then why don't we also do, how about, I'll put an E over here, negative 4x is less than or equal to negative 16. And finally, just for extra fun, let's do negative 1/3 x is greater than or equal to 5. So that'll keep you busy for a moment, but hit play when you're ready. Okay, so a reminder. It's all about what you're multiplying or dividing by. So starting with C here, I divide both sides by this negative 5. So that's a negative number. So my inequality sign will flip. This will be x is greater than negative 2. And here's your number line. That is an open circle or a round bracket, and your interval notation. Okay. Now with D, to get x by itself, I divide both sides by 7. 7 is not a negative number, right? This is what I'm trying to get at. Even though this is negative 21, that's totally fine. What drives us is that this has to be negative, and it's not, so we don't flip it. So I get x is greater than negative 3 for my answer. And here's my number line. I'll put an open circle here. And here's my interval notation. It's a terrible looking infinity. I can do better than that. Okay, I guess I can't. All right, so now here for E, so now to get x by itself, I divide both sides by negative 4. So it's a negative number, so now I've got to flip the inequality. So this is going to be x is greater than or equal to 4. And so now this is going to be a 4. Go this way. I've got my interval notation coming at you. There you go. Okay, and now for the last one. So now I've got negative 1/3 x is greater than or equal to 5. So remember, the whole goal here is you just want x. You don't want negative x, you want plain old x. So to get rid of the fraction, you're going to multiply this by negative 3. And that will allow you to cancel out the both the negative and the fraction. And when you do this, now that I've multiplied both sides by something negative, so it's still the same idea, right? So now I have to flip the inequality. So my number line is going to be right here for you. And here's my interval notation. Okay. So this is the whole idea with multiplying and dividing. So in the next video, what I want to do is put everything together now and start solving some harder problems. So I will stop here. Thanks for watching. I'll see you guys in the next one.